Okay, so now we'll be moving on to the second section on the chapter of speed of reaction, which is looking at the collision theory and how we can use collision theory to explain how different factors affect the speed of reaction. So first part, collision theory. Collision theory is basically stating that for a reaction to occur, the reactant particles must collide, means they must meet each other, and they must have sufficient energy. Okay. Now remember in the chapter of energy changes, we have learned this thing called the activation energy, which is the minimum amount of energy required for uh, minimum amount of energy that the reactant particles must have in order for chemical reaction to take place. So we know that for reaction to take place, you need to break bonds, you need to let the reactant particles meet each other and all that. So there's this minimum amount of energy that's needed before reaction can take place. So the particles must have sufficient energy, okay, to overcome this activation energy for reaction to take place. Second is you require your particles to be in the correct orientation. So what does this mean? This means that when your particles meet each other, they must be in such a way that the reactive sites are in contact for reaction to take place. So for example, like you have two reactant particles, okay. So what happens is when bonds are broken, okay, they are able to then react. So this is if, let's say, they're in the correct orientation. If they're in the wrong orientation, however, maybe something like this, okay, these particles seems a bit further away from the other reactant particles. So even if they meet, reaction may not take place, okay, because they're not in the correct orientation. So they will meet and then move away again, still existing as the reactants and not have any reaction taking place. So let's take a look at so for example over here, we can have reactant A and reactant B. Okay, reactant A is the green color dots that you see, and reactant B is the blue color dots. So if we start the reaction, remember in the first chapter, kinetic particles theory, we state that the particles are moving in random direction. Okay, so they will be moving, and they will form a product P when you have a green and a blue dot meeting each other, and they must be in the correct orientation, and they must have correct or minimum sufficient energy for reaction to take place. So sometimes, like for example here, you may see the blue and green meeting. Like for example here, you just saw the blue and green meeting, okay? But if they are not in the correct orientation, or they do not have sufficient energy, the reaction doesn't take place. So they separate out as blue and green again, okay? So like for example, they meet, that was the correct orientation, so you saw it turning red, right? Okay, so the reaction will continue until your blue and your green dots appear, reacts and form your red product. Okay, so let's go back. Right, so that's your activation energy. So remember your energy profile diagram. So your reactants must overcome this activation energy before it can form your product. And this is exothermic reaction because your reactant will lose energy or give off energy in order to form your product. So delta H is negative. Similarly, for an endothermic reaction, your reactant will still have to have minimum amount of energy, okay, so that it can form your product. And here, your reactant will gain energy to form product, so delta H is positive. Now, the collision theory is important because hence, we need to look at factors that can affect how the frequency of effective collision will take place so that it affects the reaction rate. So what is effective collision? So just now we have seen Effective collision means that your particles must have energy greater than or equal to the activation energy. So they have sufficient energy for reaction to take place, and they must be in the correct orientation. So when particles collide or when particles meet with energy greater than or equal to activation energy, and then the correct orientation, reaction can take place. These type of collision are called effective collision. For collisions where the orientation is not correct or the energy is insufficient, okay, then the collision will not result in reaction. So those are the ineffective collision. So for speed of reaction, what we want to focus on is really the effective collision. Okay, so the more effective collision you have, more reaction is going to take place. So the speed of reaction increases. So what are the factors that can affect speed of reaction, which means they can affect the rate of effective collision. So there are 5 factors. One is concentration, second is pressure, third is particle size, because that will affect the total exposed surface area, fourth is temperature, and fifth is the presence of a catalyst. Okay, take note when conducting an experiment to investigate the effect of one of the factors on speed of reaction. All the other factors must remain constant, so that is a fair experiment. We can do a fair comparison. Okay, and when we are looking at the 5 factors, we look at two things. One is the speed of the reaction. So remember, the speed of the reaction will affect your gradient of your graph. Okay, so the faster the speed of reaction, the steeper the gradient of your graph. The slower the speed of reaction, the gentler the gradient of your graph. Okay, so we look at how the 5 factors will affect the gradient of the graph. And the second thing is we look at the amount of product form, which affects the height of the graph. Meaning, when does the graph becomes having a gradient of 0. Okay, so the height of the graph will be showing you the amount of product form, and we can actually calculate the number of moles of reactants or products, okay, that is either present or being produced. And usually this is affected by your amount of limiting reagent. Okay, so let's look at the first factor first.